Okay, I'm going to be going over notes from Chapter 1, Section 1. And the first topic that we're going to discuss for the section titled Describing Matter is matter. Matter is anything that has mass, and volume. So it has to have mass and take up space. Alright, so knowing that definition, let's think of some things that are matter. So you can write down a couple examples now. And I'm going to do some of mine. So I say a car. Yep, that's matter. Cars matter. You might think, well, what about like a penny? Copper. Pennies are made of copper and zinc. So copper, is copper matter? Yes, copper is matter. What about the milk that you had today? Or will have today? Milk. Yep, that's matter. The cow that had it. Yep, that was a bad cow today. Let's give him some swatches. Yep, he's matter. So, all these things have mass and take up space, so they have volume. Alright, so things that are not matter. Well, the sounds that we hear, that's just air pressing against other air. Now, let me talk about that one. Air is matter. It takes up space. We may not see it. Just because we can't see something doesn't mean that it's not matter. So yes, air takes up space and it has volume. It has mass. Things that are not matter, though, would be like the actual energy in sound. So sound, that's just the compression of air. Now the actual air is matter, but the energy sound is not. Let's think of other forms of energy. What about light? Light doesn't have, right now I'm going to tell you that it doesn't have mass and it doesn't take up space. And what about just any kinetic energy? That's not matter. And you might think of some others, and go ahead and write those down now, but we'll talk about them at the end of the video. Hopefully I'm actually there today. Okay. So the simplest form of matter, we're going to discuss that next. Now that's not in your book on the next page. It's in your book, but it's not the next page. I want to talk about atoms because that is the simplest form of, it's the most basic, let me write that down, the most basic your particle. Yeah, it's the word that your book uses. Most basic particle of matter. The most simplest form of matter is the atom. So an atom, right now, you'll notice in our models, an atom might just be a sphere. So just a ball. Here's one model of an atom. Another example, and this might be a carbon atom. I think that's the example that your book uses. Another way to draw an atom is with all of its little subatomic particles. It's a fancy word. It's just a way of saying the things that are making up an atom. So the things that can make up an atom are, and we'll go over this more, are electrons, and they're on the outside. Draw some electrons, and they're negatively charged. Don't worry, we'll go over this in another chapter, but these are electrons. And they got a negative charge. And then in the center are protons. I'll color those in. And neutrons, I'll leave those blank. So that's a neutron. It is neutral. And that is a proton. And that is positive. So here is another example of an atom. And this one, it has 1, 2 protons, so this is helium. Oh, I guess I could write it out. Helium atom. Alright, so an atom, the most basic particle of matter. And then, well, we can group atoms in 2 types of elements. How does your book describe this? An element is a pure substance that cannot be broken down into any other substances by chemical or physical means. So elements are the most pure substance. It's one kind of atom. Alright, so atoms are the actual physical particles, and then we can call them elements. So those are the types of atoms. Like there are iron atoms. Iron is the element, and the actual particles are the atom. Alright, so there are iron, Fe. That's the symbol. And you can just look on the periodic table of elements. You know, that table that looks like kind of like this. There's 2 columns over here, and then like this kind of, and then there's 2 more down here. I got them all over my room. So the periodic table has all the elements. There's like 116 or something like that. Don't quote me on that, but there's a little over 100. So that's the different types. I think on this next page, yeah, symbols for elements. So we can go over that. So make sure you get this down. Pause. Okay, and we're gonna go on to more examples of elements. So another one might be helium, He. Another one might be just H, hydrogen. So there are hydrogen atoms. There are helium atoms. And we'll tell the differences between the two in the next chapter, but I just want to go through iron. I've already done that one. What's another? Magnesium, Mg. And there's Cu for copper. And right now you're freaking out. Why is copper Cu? Well, these had older names. These elements had older names. And I'll get into this more in the next chapter, but it used to be called cuprous. Yeah, so that was its old name, so that's why it's Cu. And like magnesium, that one still fits kind of. Hydrogen still fits helium. What's another one I can? I think W is tungsten, and that's because whenever it was originally discovered, I think it was discovered by Germans, and they had a name for it that started with W. I don't remember what it was. I think sodium, Na. You don't have to copy all these down, but write down a few of these examples. That's sodium. And it's Na comes from like the Latin or Greek for they used to call it napium or something like that. So the symbols don't always match, but for the most part they do. A lot of them fit the English words for the elements, but they've been discovering elements way before English was the predominant language of the Western world. So yeah, and if you notice, there's 2 things you probably notice. One, the first letter is always capitalized, and the second letter is not. You either got 1 letter or 2. Most that you can have is 2. Alright, so let's go on to molecules. So, molecules. Now this is going in a different order from the book. I think we're flipping back even further in the book. We are on page, if you're looking in the book, what page are we on? Oh yeah, page 11. So whenever we get 2 or more atoms, chemically bonded, Where we get two or more atoms chemically bonded, or another way of saying that is stuck together. That's the unscientific way of saying it. That we're going to have two or more atoms stuck together. But the scientific, we need to say that's a chemical bond, because in order to break them from being stuck together, we're going to have to do a chemical change. But we'll get into that probably in the next video. But yeah, molecules, two or more atoms, chemically bonded. That means stuck together. So we can do some examples of molecules, like we have water. Water has an oxygen. And I'm going to remember, we can represent atoms with like this over here, or we can represent it just with a sphere or a circle. So the simple way right now is just to do a sphere or a circle. So this tiny circle inside the oxygen symbol, and it is bound to two hydrogens, and it does kind of look like Mickey Mouse. So that's a molecule. And we could also do oxygen bonded to itself, so two oxygen atoms. Let's make sure they're touching. Okay, there's an oxygen, there's an oxygen. I know it looks like googly eyes, but it's my representation of oxygen. We also have, in your book, does carbon dioxide. That's something we breathe out. Excuse me. And so we can have two carbons. C represents carbon bonded to one oxygen. So there's some molecules, and they get even more complex than that. We could have, and we can draw them different ways. Sometimes you'll see me draw them like if I wanted to do, well, I'll just do oxygen again, bonded to two hydrogen. Sometimes I draw them without the circles, but it's still the same thing pretty much. Okay, a chemical bond. So this is how your book explains a chemical bond. It's a force of attraction between two atoms. A force of attraction between two atoms. Now, so for all these molecules to stick together, there is a chemical bond. And how I represent that usually is, or how you'll see that, is with a line between drawings, or sometimes we just draw the circles together. That can kind of represent it too. So I'll do a couple more examples, like if you have sodium chloride. So we could have sodium, and I could draw it like this, or I could actually draw circles around it. There's an atom, there's an atom, and then usually this line in between represents the bond, the chemical bond. And that's what you eat, sodium chloride, NaCl, that's table salt. Alright, so we got molecules, and they're held together by chemical bonds. And so we've just discussed all the pure substances. So pure substances are made of, well, how your book calls it, and I'm going to go back to the book here. Your book just calls it a substance, but I like to call it a pure substance. That way we know it's pure. It's a single kind of matter. Excuse me. It's a single kind of matter. Is a pure substance. Let me draw a line here. Alright, so, and we just did examples of those. So we got molecules, they can be a pure substance. So if you had pure water, that's a pure substance. It's just going to be made out of hydrogen and oxygen. So if you had a whole bunch of hydrogen and oxygen together, I'm fitting this in barely at the bottom. If you just had a whole bunch of these together, that would be, and your sample was like this, that would be a pure sample. Okay, if you just had a whole bunch of those. Let me erase this. Let me draw another thing. I'm running out of room, but you can just go to the next page. let me see here. We could also draw a whole bunch of, if you had a piece of pure iron, all of its atoms would be the same, and so that would be a pure substance. So if I had like a wire of a wire of iron, just one type of atom, that's a pure substance. So a pure substance is if you have one kind of atom in a sample or one kind of molecule in a sample. All right, so we're going to stop there. We're going to pause and take a little breather.